And we're recording. Okay. So I'm going to start by putting up an opening exercise for you. So we're continuing the lesson that we started on yesterday. So your opening exercise is going to be really straightforward. All that I want you to do is FOIL these two binomials. Okay. Okay, give me some numbers. Let's say that we have x plus 5. Okay, more numbers.
2.
Let's say x plus 5 times x minus 2. More numbers, more numbers. Let's say x plus 4. And one more number. X minus 7i. Okay. Let's say, okay, one more number. 8. Let's say x plus 8 times x minus 8. And one last number. X plus 3i times x minus 3. Okay, take it away. I'm going to go ahead and get attendance punched in. Okay, we'll check our work in 4 minutes. Okay, Trinity.
Here.
Zonnie.
Here.
Mortiz.
Here.
Kylie.
Here.
Chelsea.
Here.
Liliana.
Here.
Edwina.
Here.
Zebedee.
Here.
Deshana.
Here.
Megan.
Here.
Audrey.
Here.
Lina.
Here.
It's like everyone's here. Simplify them as much as you can. Okay. Well, go ahead and call on a name here. Sonic. What would you do? How would you do it?
I use the FOIL method and I multiply x by x and then multiply -2 by x.
Okay.
And then I do 5 times x and then -2 times 5.
Okay.
And I combine the two.
Okay. Yeah, let's go ahead and just hold off there and actually multiply them. Okay, y'all. What's x times x?
X squared.
Okay, x squared. X times -2.
-2x.
5 times x.
5x.
5 times -2.
-10.
-10. Okay, so -2x plus 5x. What's -2x plus 5x?
3x.
Okay, so x squared plus 3x minus 10. Can we simplify this any further? I don't want to. Okay, so that looks good. So when we have something like this, x squared plus whatever x plus whatever, what are those called? Starts with a Q. A Q, yeah. No, we're starting a new unit, so we haven't covered this particular bit of vocabulary, but you should have seen it in Algebra 2 and in Algebra 1. Starts with a qua. Quadratics. So this is a quadratic. It's not a quadratic equation, because we don't actually have an equation here, no equal sign. But we do have a quadratic nonetheless. Okay, so let's do the same thing here. But now we have an I kicking around in there. What's x times x?
X squared.
Okay. Then x times a -7i. That's a -7xi. Bit of a mess. Okay, what's 4 times x? And what's 4 times -7i? -28i. Okay. So can we simplify this at all? And none of them are like terms. This I, the I and this x here, they're messing things up. Okay, on to the next one. Okay, so same thing. X times x. X times a -8. 8 times x. And 8 times -8. Okay, so can we combine anything here? So what can we combine? What can we combine? We have a -8x and an 8x here. What's -8x plus 8x? 0. So we end up with x squared minus 64. So is that still a quadratic? Raise your hands if you think that is not a quadratic anymore. Raise your hands if you think it's still a quadratic. Okay. Well, yeah, it is still a quadratic, just what's its middle term? 0, 0 times what? X. The middle term still has an x, it's just 0x. And 0 times x is just 0, so we don't write it, but it still is a quadratic. Okay, but that's interesting. The middle term, it canceled out. Why do you think that is? Well, is it because we had a positive and a negative? Is that what caused it to cancel out? Well, this one also had a positive and a negative, and the middle term didn't cancel out. It's because they have the same number. They're a positive and a negative, and they're the same number. Now that looks awful similar to something that we learned about complex numbers. What does it look an awful lot like? It looks an awful lot like a complex conjugate, doesn't it? Which has the same properties. Speaking of complex conjugates, x plus 3i times x minus 3i. So, what's x times x? X times a negative 3i? That's a negative 3ix. What about 3i times x? That's a positive 3ix, and 3i times 3 at negative 3i? Okay, what's 3 times 3? 9, and what's I times I? Ah, yeah, I times I is negative 1. Because remember, I squared is negative 1. So that becomes a negative 9, but then a negative 1 attached to it, so this becomes a positive 9. Okay? Does anything simplify here? Yeah. X squared plus 9. Okay. And hey, those middle terms, they canceled again, didn't they? Why? Well, the numbers are the same, right? 3i, but what's different? The sign. So, whoa. Okay, so we're going to use these as examples for this for our next exercises. So go ahead and grab your books and open up to Module 3, Lesson 1, Page 2, S.2. So remember, we are no longer in Module 2, we have just advanced to Module 3. Is it still recording? It is still recording. Of course, we still have an hour and 15 minutes, so it'll be interesting to see if it is still recording in an hour and 15 minutes. Okay. So, let's go ahead. So, these exercises 1 and 2, that's basically what we did right here. So we're going to skip exercises 1 and 2. We did them yesterday. So let's go ahead and move on to exercises 3 through 6. Now for these exercises, it's telling us to write each of the following quadratic equations as a product of 2 linear factors. Okay, what the heck does that mean? Well, let's go back here for a moment. These guys here are the linear factors of this quadratic. 2 linear factors of 1 quadratic. So we're just factoring the quadratics on the page. Make sense? Okay. But they have interesting twists. Okay, Trinity, could you read out number 3 for me? Oh, we're on page S2. I guess I'll go ahead and write that down. Module 3, S2. We're looking at exercises 3, 4, 5, and 6. Number 3, read it out for me so I don't have to. So we have z squared minus 4. What's 4 for? What's 4?
Z squared plus 4.
Z squared plus 4.
Z squared minus 4i.
4i.
Z squared
Plus 4i. Oh, they're not that bad. Okay. So, is this a quadratic? This sure is a quadratic, but what's its middle term? Its middle term is 0 or 0x if you prefer. So what is that? So if we were to factor this, what does that tell us? Okay, well first of all, what's going to go right here? What's
Z.
Z? Z's are first. Is just this term or it's going to be in both, right? Okay, so its middle term is 0, right? So what does that tell us about the numbers that are going to have to go here? They're going to have to be the same, won't they? And so they're going to have to be the same. What else does that tell us?
The signs are different.
The signs are going to be different. One's going to be positive, one's going to be negative. Okay. So, well, I guess in order to figure this out, we need to know what the factors of negative 4 are. So what can we multiply together to get
2.
negative 4?
2.
We can do 2 times what?
2.
2 times 2 is negative 4?
Negative.
2 times negative 2. What else?
1 times 4.
We can do 1 times 4, but that's 4. We don't have a 4. We have a negative 4. 1 times negative 4. Anything else?
1.
Well, we can do a negative 1 time. We can do a negative 1 times 4. Okay. So which of these combinations have the same numbers but with opposite signs? 2 and negative 2. Okay. So z plus 2 and z minus 2. Fair enough? How can we check this?
Oil.
Let's FOIL it and see if they're the same. So z times z, z times negative 2, negative 2, 2 times z, plus 2z, and 2 times negative 2 is negative 4. Okay. Does anything cancel? These guys? So, did it work? Is that correct?
Yeah.
Sure looks correct to me. So it looks like we factored them correctly. These are the linear factors of z squared minus 4. Okay, fair enough? Okay, I want you to take 1 minute and see if you can figure out number 4 for me. Remember, you need for the two numbers to be the same, and you need their signs to be opposite. Let's see if you can figure out what you have to plug in. I'll give you about 1 minute. I'm pretty impressed so far. I saw a lot of people can figure this out. think I'll call on somebody. Edwina, you get it figured out? You had, sorry, say that a little louder.
Had z minus 2.
Uh-huh.
Z minus 2.
Z minus 2 times z minus 2. Let's check it. Okay, so that makes some sense, right? You want negative 2 times negative 2 to give us a positive, right? That makes a certain amount of sense. Let's check it. Z minus 2, z minus 2. So z times z, z squared, minus 2z, minus 2z, plus 4. So negative 2z minus 2z? Negative 4. That's 4z. Those can cancel. It's a good thought, though. So there's something, so, man, I don't know, this seems kind of weird. How is this going to even work? This is a positive 4, right? But we need the two signs to be different so those middle terms cancel out. We need something that, when multiplied by itself, will give us a negative number. It doesn't work for real numbers, but it can work for imaginary numbers. So, what do we need there? We need an I. So, instead of z minus 2, it'll be z minus 2i. Should I just do it on the 1, 2 on this side? Yeah, I have to have it in both. Because as we saw in this problem here on our bell work, if those i's don't match up, then it won't cancel. They're not like terms, yeah?
Different signs.
And they have to have different signs as well in order to cancel out. So a minus 2i and a plus 2i. Fair enough? Okay, so again, we'll check it. Z times z is z squared. Z times 2i. That's a positive 2iz. And what about negative 2i times z? Negative 2iz. Sometimes I'll write 2z, 2iz. The order doesn't matter. Okay, and then what's negative 2 times 2? That's a negative 4, but what's I times I? There's negative 1, and the negative times a negative is a positive 4, and these guys cancel, leaving us as z squared plus 4. So, do we get it? Okay, raise your hands if you figured that one out. Yeah, it looks like about 1, 2, 3, 4, 5, 6, 7. About half of us. So, let's see. So, it looks like if it's z squared minus a number, then we can just use real factors. If it's z squared plus a number, we're going to need imaginary factors. What if we have z squared minus an imaginary factor? Oh, dear. Okay. Looks like I don't think we have the tools to handle this right now. Let's see if we can figure them out. So, what's going to go right here and here? Z, yeah. Nothing fancy there. We need z times z to give us z squared. Okay, now then. The signs, so they have to be the same or different? They still have to be different. We still need those middle terms to cancel out, so it has to be a plus and a minus. And we also need them to be the same, right? So we're looking for something times itself to give us 4i. 2i? What's 2i times 2i? That's 4i squared, which is negative 4, yeah? So that doesn't work. We can't do I times I. What can we multiply by itself to get I? Okay, well, let's develop a little bit of mathematical technology, huh? Okay, so what are we trying to find? We need something that when multiplied by itself, okay, well, actually, we have a negative, positive, and a negative there, so one needs to be negative, the other positive. And we're trying to multiply something by itself to give us negative 4i, right? Fair enough? Okay, well, I have this negative sign on both sides, so, I'll go ahead and use a variable. Something times itself is going to give us negative 4i. Is there anything on both sides so we can cancel off? I see these negative signs. Okay. Okay, what's x times x? X squared. So we have x squared equals 4i. Okay, so how can I find out what x is? Square root. What's the square root of x squared? And what's the square root of 4i? Okay, well, we can split this into two square roots, right? Sort of. So we would have square root of 4 times the square root of i. What's the square root of 4? What's the square root of I? Just the square root of I. Doesn't simplify. Does that make any sense? So what are we going to be putting here and here? The 2 times the square root of I. Fair enough? So, if in order to get an I in our quadratic, we need to make sure that we multiply square root of I, or in the third term, the last term of our quadratic, we need to make sure that we're multiplying square root of I times square root of I. Fair enough? That makes sense. I mean, technically, it's a plus or minus square root of I, but all that would do would just change the signs on these, so we're not missing any solutions. Okay, so what about this one? I'll give you a minute to figure out number 4. We have z squared plus 4i, so it's kind of a combination of these two problems here. See if we can figure it out. 1 minute should be enough time. Then I'll call on someone to share their thoughts. Still recording. Sweet. People right there? What that poor desk ever do to you? So we know their signs have to be different. We know they have to be the same thing. We'll need a square root of I in there. And we're also going to need something that is going to reverse the sign and multiply by itself. Okay then, raise your hands if you think you figured it out. A positive forest of people not holding up their hands. Yeah, this one's weird. I kind of love this problem though because it's so very strange, but also kind of obvious. Okay, so let's take a look. So again, is there a middle term? Or what's the middle term there?
0.
0. So we need them to cancel out. So what does that tell us about the signs? And what does it tell us about the numbers?
Same.
Same. So we have and what's going to go out here? Z. It is Z. Okay, so the signs will have to be different. So plus and a minus. Or a minus and a plus. Okay. So we need something that times itself will give us 4. So what's that going to be? 2. So it's still going to be working with that same boring old 2 we've been working with. Okay. Now, we also have this I. So what times itself is going to give us I? What times itself equals I? So I is going to be the square root of I. Does that make sense? So we need the 2. What else do we need in there? We also need a square root of I. Okay, well, so far it looks just exactly the same as this, right? But this one gives us a negative term when we multiply them together. We need something that when times by itself will reverse this sign. So what else do we need in there? I heard Zani say it. Say it loud.
I.
You need I. So it's 2 square root of I. Isn't that just kind of weird looking? I love this problem. But then I have a tremendous door. Okay. So let's go ahead and check this. What's Z times Z? Okay. What's Z times a negative 2 square root of I? That's good. Let's see. Z times, it's just going to be this, but with a Z nailed to it, right? So Z 2 square root of I. Fair enough? Then the same thing, but this time it'll be positive. Plus Z 2 square root of I. And finally, the fun part, what's 2 square root of I times a negative 2 square root of I? So first of all, a positive times a negative, what's that? Positive times a negative gives us negative? Okay. What's a 2 times a 2?
4.
Square root of I times square root of I?
Square root of I.
Square root of I times square root of I, that's square root of I squared, which is just I. And I times I? I squared, which is? Negative 1. There it is. What happens to these two messes?
They cancel out.
They cancel out, leaving us with Z squared plus 4I. Oh, that's beautiful. I love it when math comes together like that. Okay. So, does this make sense? So we have here kind of 4 basic types of factoring a quadratic problem. Now, for all of these, it's just Z squared plus a thing. And we have 4 different results. Z squared minus a real number, Z squared plus a real number, Z squared minus, what type of number is this? Z squared minus an imaginary number, and Z squared plus an imaginary number. And for each of these, it follows a pretty simple set of rules to be able to find what it equals. So, with these examples up on the board, do you think you can handle a few of these on your own? I heard a yes. I heard a couple of terrified no's. Well, I'm going to do it anyway. Okay. So, let's take a few. I'm going to put up a few quadratics. I'm going to want you to factor them. Sound good? Okay. Let's see. With my handy dandy random number generator. Yeah. They'll be in the books. This will just be a few problems. If we have time, we'll be up at the boards by the end of the class. Okay, then let's say that I have z squared plus 25. Let's say we have z squared plus 81i, z squared minus 36, and finally, let's say z squared minus 9. I want you to factor the quadratics. Fair enough? Okay. I think 4 minutes should be pretty generous. So, have at it. In 4 minutes, we'll check this work, see how you did. Still recording. Yes, that one should be z squared. My apologies. It'd be really difficult to factor something that couldn't be factored. Well, this could be factored. It doesn't mean z squared is z. It would be two different terms. Fair enough sense. As a general tip. So this is just like, oh, like what the right writing device. When we have square roots and then a number, it's would be a good idea to put a little tail in front of square root, so it's clear where it's at. Does that make sense? It's something that just assumed that you have a really nice handwriting, so it's probably not including the word you, but it's really important. Keep it track. Okay, so let's go over them. So for this first one, we have x squared plus 25. So, again, no middle term for when we factor it. So the numbers have to be, and their signs have to be, and all of these are going to do that, won't they? Okay, so what are we multiplying together to get 25? 5 and, okay, 5i. Because we need a positive times a negative to give us a positive. And the only way we can do that is if we have a 5i in the mix. Fair enough? Okay. Now this next one is pretty similar. Where again, it's going to have the same basic structure: a positive and negative, two z's, and the second term is going to be the same in both. The numbers will be the same. Okay, so what do I have to multiply together to get 81i? What multiplied by itself gives 81i? It's going to have what in there? A 9, the square root of I, and an I. Okay? Okay, then,
Z plus 6, Z minus 6.
Oh yeah, this one's easy. Just z plus 6, z minus 6. No need for i's. Positive times a negative will give us a negative, so we're all good. Okay then, and for this last one? Z minus 3 square root of I. Because this is a minus 9i here, so we need something times itself to give us I, so we better have the square root I. Fair enough? So I know that it got kind of, that these might look kind of scary, a little scary when we were figuring it out, but are these really that difficult once you learn the rules? Eh. Raise your hands if you got these mostly right. Okay, keep them raised if you got them exactly right. Pretty good. Okay. Okay, so here we were factoring quadratic expressions, but quadratic expressions aren't all that useful, honestly. I mean, they're okay, but what we really use a lot is quadratic equations. So what's the difference between a quadratic expression and a quadratic equation? We need an equal sign in there. With a quadratic equation, what does one side usually equal? 0. So let's go ahead and continue this problem a little bit. What if all of these were equal to 0? So if all of these were equal to 0, then once we factor this thing, these guys down here would also be 0, right? Fair enough? Or they would still equal to 0. We just rearrange the left side of our equation. So what are the solutions to this equation? What was the solution again? We looked at this definition yesterday. What is the solution to an equation? Yeah. What's making the equation true?
Numbers.
The numbers we put where?
Plug into the variable.
It's the solutions to an equation are the numbers you plug into a variable that makes an equation true. So what could I plug into here to make the equation true? What could I plug into z to make this left side come out to 0? If I plug in 0, what's 0 plus 5i? 5i, and what's 0 minus 5i? Negative 5i. And is 5i times negative 5i, will that give us 0? That won't work. Let me ask you a quick question. If I replace this whole thing here on the left with a 0, then what will I get when I multiply both of these terms? They'll both be 0, right? If one of them equals 0. So what can I plug in to z plus 5i to make this part here 0? Minus 5i. I could do negative 5i plus 5i to get, what's negative 5i plus 5i? 0. So 0 times who cares is what? 0. So we have one of our solutions. So one of our solutions is negative 5i. Okay, great. So what can I plug into the z here to make this right side come out of 0? A positive 5i, because 5i minus 5i is, and 0 times who cares is. So our solutions are negative 5i and a positive 5i. Fair enough? Okay, then take a moment and write down the solutions for these three others. That should take you about 30 seconds. So. Okay. So what are the solutions to this one? Well, negative 9, square root of I times I, because when I plug that in, what will happen to these two numbers? They'll become 0. And 0 times, again, whatever, is always going to be 0. So that's the reason why we factor quadratics. It's because we're trying to find their zeros. We're trying to find the solutions to these equations. Fair enough? And I don't know about you, but looking at z squared plus 25, well, this one's it's not too bad. I just know that, hey, or what squared plus 25 is going to equal 0? Well, you could definitely tell it has to be a 5 in there. Maybe with a little while you can figure out you need the I. But here you can just look, and there they are, staring you right in the face. Does that make sense? That's the entire point of the factoring equation. So what are the zeros? What are the solutions to this equation? And for this one? Yeah, plus or minus 3 square root of I. You could also write these as just plus or minus. This is important to remember that plus or minus means that this is two different numbers. This is not one answer with a funny symbol. This is two different answers that are just being shortened down to one symbol. Make sense? Okay. 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 I'm going to erase this. Does everybody have this down? Okay, good. Okay, we're going to do one more little thing, then I think we'll take our break. Whew. A lot of learning jammed up in my brain today. Okay. Okay, so this will be in your notebooks. I want you to find the solutions to the quadratic equations. Quadratic equations by factor. Okay. So, let's say we have x squared plus 49 equals 0. I want you to find the solutions to that. And I also want you to find the solutions to x squared plus 14x plus 49 equals 0. Fair enough? This is basically the same thing as exercise 8 in your books. I just changed the numbers around. So find the solutions. Let's make it, I think, 3 minutes should be enough time. We are still rolling. I wonder how big this file will be. Ugh, it's going to take hours to upload. Oh well. Everything okay then? Thank you, guys. Interesting. You see how we still got 2 expressions? They just happen to be the same thing. So we really have 2 solutions, just they both happen to be the same number.
Wait. Okay. I thought it was problematic. Not just the adding.
Okay then. So, the easiest way for us to do this is by factoring it. So let's factor it. What's this going to give us?
X plus 7, X minus
X, what? X plus what?
7.
Just 7?
With X and Y.
Plus 7i. X minus 7i. Okay, let's check it. X times x? X squared minus 7ix plus 7ix plus, let's say that's minus 49i squared, but that's minus 49 times negative 1, which is plus 49. So that works out. Okay, great. So then this equals 0. So what's x? What does x equal? Plus or minus 7i. Okay then, now for this next one. Wait, this next one has 3 terms. No fair. We've only been doing these since middle school. So, okay, well, let's factor it, I suppose. You're not allowed to go around giving old problems, Mr. Rue. Okay, so what's this going to be? X plus 7? And x plus 7 plus x plus 7 are the same. Well, let's check it. X times x. Plus another 7x. Plus 49. Does anything combine? Those 7x's. X squared plus 14x. Okay, cool. So it checks out. So then what are our solutions? Plus or minus. No, not plus or minus. Just minus. X is only negative 7. So note that it's still factored out to what's the word? To 2 linear factors here. We still got 2 answers. It's not our fault that they happen to be the same number. It's negative 7 and negative 7. They're just the same number, so go figure. Okay. So, make sense? Okay, now, all of this whole mess was all about figuring out a formula. So, okay. So all of this whole thing, all these rules that we figured out was basically a roundabout way of us trying to figure out 2 formulas called the factors. What actually is it called? Oh, it doesn't say what it's called. Well, one of them is finding the factors of a difference of squares, and the other is finding the factors of a sum of squares. So here are the formulas. We'll write these down, then we'll take a break, then we'll carry on. So if I have z squared minus a squared, for example, this problem right here. For this one, what would a be? What squared gives us 36? So for this one, a would be what? 6. So z squared minus a squared can be factored out to z plus what? A times what? Fair enough? A times a gives us a squared. 6 times 6 gives us 36. Okay, so this is the factors of a difference of squares. And now for the sum of squares, which